a simple problems. We have a box, its weight is 40 newtons, and we pull it with a horizontal force of 20 newtons. We know g, the acceleration due to gravity, 9.8, which is pretty much close. We will consider it to be 10. What is the acceleration? So we start by doing the free body diagram. The free body diagram should be horizontal and parallel to the horizontal surface. The forces are, so I start by drawing the object as a point-like mass in the origin. The forces are, we have the force due to gravity, which is the weight. The weight means the force due to gravity. So I do know that the force due to gravity is 40 newtons. And there's a horizontal force, F, of 20 newtons. Is there anything else? Yes, there's normal force. We have a surface, so we should have a normal force. They don't say anything else, let's consider that friction is 0. If they don't say, there's no friction. Friction is negligible. We don't create it, unless they tell us so. How do they say so? If they tell us that's the friction, or if they say it's not negligible, or it's the surface is rough. We know that there is friction. Okay, so this is the free body diagram. All forces are on the axis, so I'm good to go. I'm looking for the acceleration. Apparently the acceleration will be horizontal. So I have the option where the sum of forces on the x-axis will create the acceleration. We have Newton's second law. Well, on the y-axis, the sum of forces should be 0. As we said, we have three options. Either both sum of forces on the x-axis and on the y-axis are 0, or we have some acceleration on the x-axis only, or we have some acceleration on the y-axis only. So we have these three options, 1, 2, 3. Our case is the second one. All right, so this is positive. We consider this direction to be positive, the upwards and to the right to be positive. So this is positive, this is positive, this is negative. So the sum of forces on the x-axis, the only force we have on the x-axis is the force F. So F equals mass times acceleration. Well, here we have normal force minus the force due to gravity equals 0. Here, just to finish this up, that means that the normal force equals the force due to gravity, meaning it's 40 newtons. Now, what about here? All right, so I do know the force, it's 20. Do I know the mass? Yes, I do. How much is it? It's 4. Because the force due to gravity of g is mass times the acceleration due to gravity. So if this is 40 and this is 10, the mass should be pretty much 4 kilograms. It's more than, if I consider it as 9.8, I would find 4 point something. So going back here, this is this is 20, the mass is 4, and I can find that the acceleration would be 5 meters per second squared. This is a simple example that shows how we use the free body diagram, which option we will choose, and how we solve to find whatever we want. I'm fast.